A very good afternoon, everyone. My name is Ariman Bajpayee. I'm a core committee member at IIT VIT, and I shall be your host for today's workshop. What exactly do the word blockchain means? Well, to put it in simple words, it is a technology that permits transactions to be gathered into blocks and recorded, cryptographically chains blocks in chronological order, and allows the resulting ledger to be accessed by different servers. To throw more light on this subject, we have with us Zive, a very renowned name in the world of blockchain. Zive is one of the leading innovators in the blockchain space. Their full stack blockchain platforms and products help developers build next generation networks and enable enterprises to launch more powerful Web3 distributed infrastructure and applications. We are grateful to have a brand of this stature on board with us for our upcoming flagship event Blockade, a 24-hour hackathon which shall be conducted by our chapter IET VIT from 9 to 10 July 2022 that will make you experience the magical world of blockchain technology. Now, it gives me immense pleasure and utter proud to introduce to you our speakers for the session, Mr. Sankalp Sharma, co-founder and vice president engineering at Zive. He completed his formal education from Indraprasth Engineering College and has been associated with several projects related to Hyperledger Fabric, etc. Our second speaker for the day is Mr. Lakshya Gaur, who also completed his formal education from Indraprasth Engineering College and is a full-time blockchain architect at Zive. So, guys, let's get started with the workshop. The platform is all yours, sir.
Awesome. Am I audible properly?
Yes, sir, you're audible.
Great. So, hi, very great afternoon to all of you. I think you guys are very excited to see what we've got here, and I hope I don't leave you hanging. So, yeah, I think we'll get started. So, a little bit brief on myself. I'll go ahead and first share my screen here. Let me know when you guys can see my presentation pop up. Can you guys see my screen? Hello. Hi, am I audible?
Yes, sir, you're audible.
Okay, is my
And the
screen
screen,
visible?
yes, sir, it's visible.
Awesome. So yeah, hi, good afternoon, everyone. So here we are, talking about blockchains and what it has to hold, what Web3 infrastructure is in our world today as we stand, and where exactly are we going with all of this. I'm sure you must have heard about blockchain quite a bit in your, over the years. It has been such a buzzword in technology, in terms of in cryptocurrencies and stuff like that. But it's really not very well understood even by 99% of the people who are actually mostly using it. And that's why we have this session today to give you a little bit of insight of what blockchain is, what are its various classifications, and what are the different challenges that blockchain has in today's world, and how um, one needs to go about it, or at least needs to be aware of it, and what are we contributing as the what are we contributing to our community to in order to make progress in this community. So we'll start from the bottom. We'll start from the scratch. So a little bit background on myself. I am a co-founder in VP Engineering, as just mentioned. I have been working as we basically co-founded Zeev as our organization. It's a US based entity, and we saw a lot of gaps while working over the years that the current Web3 technology is not exactly what it needs to be going ahead in future. So we introduced, Ziva as a platform abroad, giving a face to our country in terms of niche technology as well. And we were looking towards what are the different challenges that we ourselves face, and whether those same challenges are also, what other companies around the globe also face at the same time. So we introduced Zeek as a platform, as a service, and we were looking towards all kind of services which a typical Web3 application would need to run. So, on my background, I'd say that well, I have previously worked on fintech, insurtech, supply chain, IPR. There's a whole bunch of lists behind this, but we have been innovating, ideating all kind of products under Zeev itself as part of our contribution to the technology that we are working with. So yeah, quite a bit there. I think we'll pick up a couple of topics there from these functional domains, but I'll leave you with that. We also work with a lot of other decentralized technologies. Blockchain is not really it. It's one subset of the distributed tech that is present out there. But we have quite a diverse experience when it comes to IoT as well as federated machine learning and other technologies which are also very cutting edge. So going out about it, so what exactly you know is the topics of discussion. We'll be going through words what Web3 is, what are decentralized applications, blockchain, its components, challenges in blockchain, blockchain DevOps, overcoming the struggles of today and tomorrow. So these are high-level topics I'll be going through. If you guys have any questions in between, you can post it out on chat. Whenever we'll take a checkpoint, I think we can go through all those questions. But we'll anyways have a dedicated time for a Q&A session in the last of our time window. All right, so here we go. So Web3. Web3 is the pinnacle of where we stand right now when it comes to what internet is providing in terms of services to everyone, right? So internet is a combination of all networks available, local, wide area network, all of that. It combines to form a global P2P informative network that can help your businesses, that can give you information. Pretty much anything and everything that we do today is coming out of internet, more or less. But what's its journey and where is it actually going is a big question. We understand that internet is very decentralized. It's so it is not. It is very neutral for the first, and it's very less on the governance side. You are very free to have your own identity on it, and you are very free to own it, and you can use it as you want, right? Even uh, and much of the governments even have a lot of problem with the nature of internet, but we have not been able to fully utilize its potential. So it's very important to understand what internet exactly is, how we have been utilizing it, and where are we exactly going. What are we projecting in future that we'll be able to utilize this technology with. So initially, when this was introduced, Web 1.0 was mainly what it had, right? So where we only had static pages and websites, which were mostly created by large organizations and as well as some small quantity of users, and they used it for the benefit of providing the information, running their own businesses, and keeping it just on for information purposes of what they do, defining themselves and putting it out there to the world. But the participation, of course, was very low, as it was just the beginning. And while the networking, side of it was very strong still, uh, it was still very much absent from around the world. And reason being, the participation towards what kind of applications, what kind of things can it support, were also very limited because not much work had gone into it. So Web 1.0 was just about having your static pages being served onto your platforms, and people going there and be able to look into it. But there was not much user interaction to go around that time. Then came Web 2.0, which was which was a big change into how we consumed our service. It was basically responsible for digitization of everything that we know and all the revolution that has been. Um, it's quite a journey that we've got in our civilization, that we've our much of our inventions are actually based on such a technology which is internet, right? And here what happened was that users were able to, they were very smart, they were able to build applications which were interactive with the users, and they could shift much of their business online, and users benefited from that. Even the businesses obviously benefit from that. And it was not more or less about just information which is put out there, and you still have to do all of it offline. It was now at this point that much of it was coming online, and very few of it was actually remained offline, right? So that was how Web 2.0 was initiated, and it has been serving us for in a very satisfying level up until now, right? So that's where we are. are most of the applications today are still part of Web 2.0. Web 3.0 is a concept that I think many of you might have been going through for quite a bit of time. And even when blockchain was not around, Web3 is a concept that has been around for quite a bit. And we've been doing a lot of progress here, but still, it has a long way to go. Um, as Web 2.0 is able to do much of its responsibilities perfectly fine, and it's for the realization of that small percentage which will actually explode the use cases for Web 3. So Web 3 is about more about decentralization, while in Web 1.0 and 2.0 it was still more or less about businesses hosting their applications, hosting their services, and providing it to the end users. Web 3.0 was about providing decentralization, authority which cannot be uh, con- governed unnecessarily, unjustifiably, and it's basically a combination of a lot of other tech that we'll be seeing in a minute. So some examples, there have been AOI, MSN, and there have been so many. Wikipedia was also one of them initially, which was part of our information economy, and that's Web 1.0. Then we had all kind of applications today that we face. Instagram, YouTube. Well, YouTube has been quite a bit, has been around for quite a bit, but Insta and other applications have been still quite new. Although Web 2.0 has been around for a good period of time. And Web 3.0, well, this innovation was something that was kickstarted. It was present still. We can call it existed a long time back, but it got initiated with with Bitcoin coming into our lives and into the internet and showing us what actually a decentralized economy can achieve uh, uh, without having any particular person or entity providing the service for that. So that was Web three. That's when Web three actually came into picture and provided us with all those services, and that's where much of our focus will be while going through the applications. So, what is Web three actually? So, it redefines the next generation of internet apps. What it will be, what it is, and what it will be. Right? And it's basically a combination of semantic web, which is comprehension of words. Right now, much of our usage around words is that we basically do searches, we do basic analysis on it, but comprehensive words, as in combination, are quite tough to process and to make use of when you're using that for your own benefit, for your own purpose, for your own business, right? And that's what semantic web is about. Still, very small percentage of it is present out there, but it's a work in progress. We are making great strides onto this. I'm sure you must have come across this concept, out there. If there are any engineers, present in our webinar today, they must be knowing this concept of semantic web very clearly. Artificial intelligence and machine learning is another big leap that we're doing, but we still have of course a very long way to go about it. Uh, it's much of it is just potential that we're still struggling to imagine how it would help business cases all around the globe. But still, well, it's taking up, it's picking up, and it's making good advancements. Trustless data to allow data sharing without intermediating. So this is one of the applications that comes as part of decentralized economy, where you have data that is not really presented, services which are not really presented by one entity, and you're basically relying on each other as it should be for the purpose of data sharing without losing any bit of accountability. Utilization of 3D graphics. So AR, VR has been exploding, especially metaverse is taking much of the engagement forward and leading our way into the future with that. Um, and decentralized finance, cryptocurrency has been booming like nothing. Lately, it's been crashing quite a bit, I'm sure. But what it has shown us basically is that you can transact, business can operate without having the need to go towards intermediary banks or even wait for transactions with unnecessarily costs associated with them, unnecessary amount of time that is usually taken in those transactions, and you can just have that without having to go through anything such. So that's what Web three is. It's a combination of all of these different technologies, different dimensions, and it brings upon a concept which is Web3, which is what we are projecting towards next. We what Where we'll go from here is another story, but as of now, what I'll tell you from my experience is that we're still discovering quite a bit of how this will work. Much of it is already online. There are businesses doing billions of transactions over using such economy, but we've still got a long way to go to figure out where exactly do we draw the line and how then we start imagining what will be after this particular point. So, a couple of things, you must have already seen, if any one of you has interacted with Web3 applications, is that it's fully peer to peer. You don't even have to do identity verification like you do with today's applications, like with Google or with Facebook or Twitter or any of that. And you basically hold your identity with yourself. And you may be anonymous or you may not be anonymous. That depends upon how you're utilizing it. But it basically supports a peer-to-peer network which can hold a whole bunch of communities. It can hold sub-communities within it, and it allows that kind of engagement towards the world. So to understand, what Web 1.0 and Web 2.0 had to offer was that uh, it basically had central service providers, and many of our applications worked in this way, where even the servers who provide the data were very centralized, and they didn't have any distribution even for study data at the time. Now it has improved quite a bit, but yet centralization still remains because the entities who are holding the services are still one, and ultimately it falls all under the same umbrella of whoever that service provider is. So you've got one cloud, one hosting platform ultimately, and you've got multiple clients all engaged to each other, but through an intermediary organization. So one service provider, multiple clients is the approach that we have been working with for so long. It is built upon the trust with service providers. So each and every participant here has to have a certain amount of trust towards the service provider of what exactly are they dealing with. They have to trust their sensitive data towards the service provider, and they have to uh, that service provider is basically the owner of that data, and they can do a lot of injustice to what they hold, which is a lot of power. Users remain with in total uh, for them it's basically a black box, right? So they have full lack of transparency. They don't see what is going inside it at a lot of times, and what remains inside they don't even know about that, and what are they doing upon the data that they're gathering. All of that remains unclear. So lack of transparency is a big issue, and it is now coming up as a big deal because uh, users across the world know the potential of what the data can actually do, what it can push around. So it's a serious topic of discussion. Lack of integrity and privacy, again the same thing. So now the issue is that, well, if you've got a central provider, how much trust can it guarantee, and how much accountability that you can hold uh, for it in case of something goes wrong. uh, to be honest, most of the time, if anything goes wrong, people don't even realize. And a very small percentage of cases that come forward are just that, a small percentage. So it's very important to keep integrity as one of the scopes. Okay, it's one thing to have ownership of the data and who's owning it and whoever is doing whatever with it, but what is coming to you as a service needs to prove its integrity as much as possible. So that's some of the challenges that we have with traditional architectures. But yes, it has been, it has so much credit towards it. It is basically what has pulled us out into the world that we stand today. And it's still doing that job very beautifully, but of course, it has a lot of things that can be improved, and that's what we do. Yeah. So um, that's the centralized architectures where you have one server, multiple customers, intermediary or central owner organization, however you want to understand it. Then you have P2P networks where everything is just connected to each other. There's no central governance to it, or at least it's at the very least it's not owned by a single party. It can be owned by a number of parties, and it would be providing all of that with the full transparency. So you've got service providers and multiple service providers and multiple clients. Uh, don't go about what is out here. I think it's not saying, but you've got multiple service providers and multiple clients, and what it basically does is that it removes the line between the clients and the service providers. It tries to merge them together in order that, well, ultimately it's humans who are providing services to humans, right? So where exactly is this all coming from? Where you have to rely on a central party for any of this? That realization itself is something that bring about this change. That, well, we can, internet is peer to peer, then we can definitely have these services which are as well peer to peer, right? And that's where these applications are and these frameworks are coming up, which can help you to build applications which uh, which are just deployed and are running out there. People are making use of it, and you don't have to worry about its hosting, and people don't have to worry about their privacy, their integrity, or what will happen with their data, for that matter. So this brings about to the discussion of much of our discussion today, which is what is blockchain, and what is it doing in order to provide all of these benefits, and perhaps even what are the challenges that we need to associate with blockchain, identify and resolve as well. Right? So blockchain is understood as basically um, nothing but, first of all, a combination of all the technologies, right? So it's nothing new. It hasn't brought about any kind of mathematics or any kind of networking or anything in our OSI networking stack which is new. It is just a combination of whatever we were already using. So it makes use of the same OSI stack. It makes use of the same cryptography that you've been using. It makes use of the same database concept that we've been using, but it adds a lot of processes and protocol over it. So if you're doing something, if you're accepting something, you're doing it by the protocol. You're doing it by a certain standard that ensures that you are consuming that service particularly well, without having to worry about where this data is, where is it coming from, and where your data is actually going. So blockchain tries to bridge that gap again. It tries to build a framework of how P2P applications can work and function in today's society, and they can offer the same benefits that a central application would do, but perhaps with some you know benefits. So it's in actuality, it's a ledger. That's how you can understand. A ledger is basically full of transactions. People who understand finance, discounts, sorry, finance and accounting really well, they would know that a ledger basically means that you have a list of transactions that you're maintaining for whatever goes in and out, and those transactions are basically that will change your state of whatever data, whatever your business is associated with. So what it does is that it maintains this ledger between all the parties, and everybody is responsible for validating that ledger. Everybody is responsible for syncing that ledger with other folks in the network, and everybody is responsible for doing transactions through that through their node towards the network. So it creates this fancy protocol which actually brings about so much clarity about, well, if everybody is following this protocol, and then you really don't have to worry about any privacy or any security related issues. You just let it do its thing, deploy your applications, and that's it. So it's basically a framework how you can understand, and it's a bunch of transactions all linked to each other. It makes use of heavy cryptography, but those things I think will come on to the next bit. So a couple of key constructs of blockchain technology: it's a peer-to-peer network, yes. Chronological record of transactions, as we discussed, it keeps a track of all the transactions from the very beginning up until the very end. It never forgets any bit of transactions. If any bit is removed at any point, then it will just say that there's something wrong. You gotta fix your node, or otherwise you are just out of sync. So even if you do impact onto your blockchain node, if you do some kind of malicious things onto your blockchain node, you're just affecting your own business, your own blockchain node. Everything else out there is still working as it would, and everybody else would just reject whatever you have to present to them because you are not using the distributed shared ledger as it's supposed to. Network consensus. So this brings about a big chunk of cryptography, and it basically provides a method of how all the entities or the blockchain nodes will come to a decision whether a transaction, whether a block full of transactions should be accepted and should be allowed in order to perform changes onto the ledger. So a network consensus is basically assurance that you don't have to worry about whether a piece of data that has been synced from a random blockchain node out there can be trusted or not. So consensus are those assurances, and there are various consensus protocol, as many of you may have heard already, like proof of work and proof of stake and its various flavors. But yeah, I think if you have any questions, do let me know. We won't be going into the depth of consensus, what consensus is, but I can understand that many of you may have still questions around it, how it works, how you can trust it, and that this is the component that is responsible for it. So we can discuss it if anyone does have those questions. Smart contracts. So, what are basically blockchain applications if they are decentralized? Where are they running? We understand, that web technology works as there is a server, there is an application running within the server which serves all our requests. It interacts with database. It does so many things, right? In blockchain, what is the computation that goes to serve you the same benefits? Those are called the smart contracts, and they are basically responsible for uh, doing certain things as they are meant to be done in an immutable fashion, and all the rules that a programmer would otherwise write in their web application would also be writing here in smart contracts for that purpose. We'll get into more detail of this, but what basically it allows our blockchain frameworks is to have capability of having flexible logic to validate and prove transactions through the network. Uh, there's a lot of security that goes into it. So cryptography is basically, you can understand, it's the blood that flows through the network, while consensus is the heart of a network. So they both go hand to hand. Security is ensured by the best in class cryptography. It's nothing special, although there have been quite evolution. There have been quite a lot of work that has been done by cryptographers in this period because the push from blockchain. But more or less, the cryptography is at the same level as you can understand and from web applications, right? So we're using the same concepts, but it's just combined and put into in such a way that we can utilize it in a P2P economy. So how does a transaction work? So we understand that if you're doing anything related to blockchain, what you're basically doing is just a transaction, right? That's the most granular bit when you're interacting with the node. If you want to change anything, if you want to, it's unless you're reading the node with whatever transactions it has, whatever data it has, you're probably doing some transactions over it in order to change the state of your data, in order to do some flow some currency through different accounts, or whatever purpose it might be. So transaction is the way that blockchain stores its changes to whatever that ledger has. That ledger is combination of actually transactions as well as the data that those transactions impact. That data can be very flexible. You can store any kind of data structures into that ledger, depends upon protocol to protocol. But it basically can be understood that transactions are the way that we can update the data present within our ledgers. And that data again can be anything from your high school records to your medical history or anything as such. Right? So transactions are a way that we're able to update those data objects onto our ledger. So how does a transaction work, right? There's someone who's doing a transaction. Let's say I would have to uh, do a transaction of certain amount of bitcoins, and or maybe I need to just run a smart contract for the purpose of updating my medical records, for the purpose of let's say I had just a visit to a doctor recently and I want to update my medical records in my portfolio, let's say. So what will happen is that I'll create a transaction over it, and that will be responsibility of my the UI, browsers, my front end applications or whatever. That those applications will form a transactions, and that those transactions then will be broadcasted with the help of my blockchain node, which can be run locally. It could be run on my server wherever I want it to be present at. and that node will be responsible for broadcasting that transactions to whoever it can get hands on, right? It will be connected to n number of nodes, and it will try to broadcast that transaction to everyone. Everyone will receive the transactions, and the validators or the miners will take those transactions as input. They'll try to publish the block in order to get the incentives that are present for them. Incentives could be in terms of the base currency, the native currency, like it happens in Bitcoin or Ethereum. So they'll try to validate the transactions. They'll try to put it inside a block full of transactions, and they'll try to publish this block out to everyone else. So they'll also try at the same time to broadcast that block of transactions that they've gathered from everyone out there to everyone in the network. So when our blockchain node, which was responsible for broadcasting our transaction, will also receive that block, it will be basically a confirmation that our transaction has been confirmed, it has been validated, and it has taken impact. And once verified, it is again just a part of our whole ledger, which keeps the track of all the transactions from the very genesis when we actually did start the blockchain itself. That's how a transaction works. Of course, there are a lot of nuances, a lot of checks that are taking place in all of this. But at high level, this is the best that you can understand it. But yeah, sure. If you have any questions, please keep them until the point that we are able to get to them. So, where are we with this technology? Uh, we're doing pretty good. So it has come a long way. And what seemed like just inflation of promises at the time, it is now actually, I can confidently say, uh, it has it has taken effect. We are at a place where we didn't imagine just a decade back. We have technology which was just in proof of concept. I remember a time where just some years back, and it's not even that long, where the technology was totally broken and people had nothing but criticism of how it cannot support their business applications. But all of that criticism as of now has gone away. We see so many communities doing so much of work, and because of that, it was just inevitable, right? If that many people are looking towards it seriously, then of course you're bound to make some great strides onto the work. So we are at a state where we have billions and billions of dollars of transactions happening every day onto blockchains and various blockchains as well. So they have been people have realized their needs, their businesses and their needs with blockchains, and they have come up with so many creative protocols out there that can serve it better. And this is anybody's guess where it will ever stop. But the projects that you can probably research and gather yourself would give you assurances that this is something really big. It's a revolution, and not blockchain in particular. It's the Web3 world itself, the decentralized economy, the decentralized applications, and those not necessarily have to be blockchains. Is immensely growing. So you might be learning how to write web applications for whoever engineers are present here, but do mind that that may just go away in next 5 years or something, and it may be replaced by something entirely different. So that's how quickly our technology is changing. And Gartner, which is one of the biggest influencers out there, has predicted that, well, by 2030 blockchain would have done most part of it, and it will be uh, one of the options also for decentralized applications, not necessarily the only one, but it will be fully complete in realization of whatever potential it has to gather. And that's where everything would just fall apart. Most of your central applications will fall apart. Even the applications which don't really need uh, blockchains would fit in with other decentralized applications and their methodologies and their protocols in order to serve their services. So some trends in blockchain that recently are present out there um, are 55% of CIOs literally agree with these, is that it's their number one priority, uh, because again it has the power to change everything uh, we do today, right? To perform those services, to provide those services, it has the power to change it all and for the better. So that's a pretty big influencer factor if you get to know that CIOs are looking onto it, and that too at such a big majority. Um 83% of respondents indicated that their companies will actually lose competitive advantage if they do not adopt blockchain as part of their businesses, as part of their services, whether it's tech companies or if it's businesses. They both agree on the same fact because well, it has been proven by a lot of business players out there. It is so for many of the stakeholders, it becomes a strategic priority itself because a lot of competitors are doing it. Even if it's for a buzzword for a lot of them, they get into the state where they cannot lose any kind of advantage, even if it's strategic. So it becomes a strategic priority, and that becomes a big factor for them to pick up blockchain. And we can see that 39% of blockchains have actually gone in production mode, which is looking back, it's such a good number. I cannot express really because we were looking into so many challenges just 5 6 years back that we thought this will take too long, and you really have to fit it into certain domains, and it will have so much struggle crossing those barriers. But here we are, where we just are doing very great, and this number is gonna exponentially grow and more. So building blockchains teams is the priority because, well, this technology is quite niche, and well, market is totally starved in this matter. You just don't find good engineers even for centralized applications, and then you have present here blockchain, which takes the world by surprise, and it is totally different way of doing things. So there is a big stress on hiring and building these teams, and that trend is very much popular. And we can see, a lot of college students which are actually looking more and more towards blockchain as a tech value chain. So the proven value chain of what are the assets which are present on these chains, and how much have they um, converted into what can be actually quantified as value, put it into money, is actually quite a bit. And people are tokenizing their large assets, whether it's real estate or if it's gold. And we ourselves have got diverse experience in this matter of, tokenizing these assets to create big value chains. So investment in blockchain, well, that's pretty huge. Much of the VCs, and we can tell from our own experience, that investment on these blockchain projects is quite huge. Um, uh, all VCs, they know that infrastructure doesn't matter if it's infrastructure or different blockchain projects in a subset. Uh, they know that it has quite a bit of an impact, and the customers, the businesses, there's no lack of it. The only problem is to be able to build that team, build that kind of skill that is present out there. We are not running out of ideas by any means. So some of the key concepts that I think we should all go through first is, well, what are the different classifications of blockchains, right? Because now you may understand blockchain, but you can't really fully understand how it may work for a certain service, certain application, and for that you need to understand different protocols. And there's so many protocols that you will really struggle. That if you're supposed to build your application with this protocol, your business idea, your business around this protocol, then it'll be totally different. And if you do it with some other protocol, then it'll be looking totally different. So there has to be a way for you to first understand what blockchains are, what are its different categorizations, and how can you fit your use cases, fit your projects into these particular use cases, these particular classifications. I'm sorry, and then go about how to build your functional as well as technical components for your whatever your use cases. So for that matter, it's very important to understand these classifications and then to start relating it to different projects. And one of the classification is a public ledger, which is one of the first obvious classification that you may understand from this, is that a blockchain which is fully decentralized, anybody can basically participate into it. Anybody can start a node and by itself become one of the parties who can do transactions over it for whatever purpose it might be. They are fully free to have that access and to be able to make use of it for their own benefits. So that's a public ledger. Some of the key factors associated with this is that the data that goes into these ledgers is fully public, and you really have to be careful about how you're using these applications. Right, in public ledger, everything is public. You've done a transactions, you can be guaranteed that everybody who's part of the network knows about that transactions. You still have a lot of benefits, such as you may still have anonymity if you like to keep it that way. So you still anonymous to the whole network, but the transaction itself of what amount that transaction was, or whatever smart contract it invoked, or whatever data structure it updated, all of that is still public to the world. So those are some factors. A couple of things that are associated is that it's also slow in terms of performance, because it has to withstand the entire world. Right? You've got Bitcoin, which is a cryptocurrency protocol, and while it cannot support a lot of smart contract capabilities, it does support transactional capabilities for transacting the currency, which is the Bitcoin itself. So every transaction that you do is actually seen by all the nodes, and no transaction remains hidden. But at the same time, you are anonymous to everybody in the network, so nobody actually can ever stop you, and you can always just connect to internet. And if you can be connected to internet, you can always be connected to Bitcoin. That's what a public ledger is. There are a lot of other factors associated as well that we can perhaps go through. So, a little bit background on permission blockchain before we get into the comparison is that permission blockchains are what you can understand is just that it's based on permissions. You cannot participate into this network unless you have the necessary rights to participate up till any extent. And participation itself can be very different. It could be at the level of that you can be a participant who can host a node, or you can participate at the level of where you can validate and publish blocks, which is a good level of decentralization. You can also just be a user who's just holding a wallet of private keys, and you can just do transactions over it without having to necessarily hold the blockchain node as well. So there are different various level of participation, and some of these trends are also followed on public protocols. But in permission blockchain protocols, it's done with a lot of decency, with a lot of sensitivity. So that's what a permission blockchain protocol is. It's also some benefits that it provides is that you keep your data intact, you keep your data private as much as possible. You share data with other participants only when it is required, and nothing more or nothing less is ever shared across different stakeholders. So you have all those kind of benefits, and it's because these protocols are actually targeted for such business use cases that you can actually design your applications as such as well. So enterprises, many of the enterprises, they look towards private or permission blockchain as they call for the purpose of fulfillment of their applications. Some of the comparison factors is that the ledger is fully distributed. Here, it is distributed according to how you architect and design it, right? Um, Anybody can read and write in public blockchain. That's something we've already discussed. Enterprise or enterprises controls the resources and the access to the blockchains, right? It's fully immutable. So because the ledger is so spread out across nodes throughout the whole world, all of the data is fully intact, and nobody can change it. Even if you change the data present within your blockchain node, you cannot really expect anyone else would change the data in their blockchain node, because just because you changed it, right? So it is very much immutable. And immutable. I'm sure you must have heard it quite a bit of time when some of you may have gone through blockchain itself. What it needs to be understood is that immutability itself is a level, and it's not something that is ever absolute. Immutability is absolutely at the lowest when you're talking about central applications. Whoever is holding those servers, hosting those servers, can go there anytime and change those data sets, right? Nothing holds them back. There can be, of course, reconciliation between different systems, but nobody can stop you from changing that data and impacting the services. But when you come to blockchains, the immutability level highs by quite a bit, and in public blockchains, it is at the maximum level, because anyone who's holding a node out there is basically keeping a track of all the transactions that has been. And if you change the transactions within your blockchain node, well, tough luck. Nobody will accept your transactions, and you're just basically doing damage to your own business, your own services. So it has to provide much better immutability. While permissive blockchain protocols, again, they do the same benefit, but they do it according to how you have, again, how much decentralization that you have put in place. and what kind of services that you are providing and how you've architected your whole topology. But again, as I mentioned, the performance is something that takes a beating, and that's where permissive protocol takes an edge. That they can do very fast transactions because they only have to cover certain amount of stakeholders. They don't have to worry about the whole world in itself. The algorithms that are preferred here, whether it's proof of consensus or data sharing algorithms, are specifically designed for this purpose. Better scalability because again, lesser number of stakeholders, it can be scaled very nicely, and that's the reason why it can support the enterprise needs. They need high volumes, tremendous volumes, and that's where permissive blockchain comes in. They're able to fill in that requirement. When something is written on block, it cannot be changed. Well, that's present in both the cases. But again, immutability is the bigger factor that will allow or disallow whether something in that chain itself is changed or not. Right. Uh, a couple of things. So it varies protocol to protocol, but the security of blockchain is defined at the level of the category that it falls under, which is public or permission. But it also falls a lot on whichever protocol that we're dealing with. So yes, public protocols have much better security in terms of immutability, but they lose a lot of edge in privacy because permissive protocols just have better privacy between selected stakeholders. Even while you're doing certain transaction, you can choose uh, who all should be informed for that transaction and who all should be kept in dark. So security, of course, categorization is something that is taken into factor. But of course, protocols are one thing that always impact the security that goes into a protocol. So let's say if I'm able to hold ownership of 51% of nodes in Bitcoin, I can basically go ahead and change. Although it's actually still very difficult, even if I hold those 51% of nodes out there. But if theoretically speaking, if you hold those 51% of nodes, you can basically choose how you want to keep the ledger, how you want to whatever data you want to put into it, and whether you want to make yourself ridiculously rich, or you want to just dilute anybody's holding account. So you can do all of those kind of things if you have 51% nodes, ownership of nodes present out there in the world, and that is very very difficult to achieve. So yeah, those are the some factors that we can compare permissive and public protocols with. Now, what are the different type of protocols, right? So uh, there are too many protocols, to be honest. The number is probably in three digits about now. We've been working for many of the protocols for a long time, which seem very common at the moment, but they were just bunch of POCs and broken piece of software that never used to work and used to usually disappoint. But we've come so far from that point where we have these protocols coming up. Every protocol has its own nuances, own improvements, own specifications that it guarantees or it promises even for specific use cases. So every protocol has its own uniqueness, and that's where they find their own space, because not a protocol itself cannot guarantee all the promises to all the business use cases that are out there. There's so many out there, right? So a lot of blockchain protocols that have come up: Avalanche, Axia, Flurry, Phantom, Corda, Hyperledger Fabric, Polkadot, Bitcoin, Ethereum. These are some of the few. Um, some particular things that I may rather mention here for some of them is that, well, Fabric is one of the leading uh, blockchain protocols when it comes to permissive protocols, and R3 Corda is just as same. It's also a permissive protocol which has been leading its industry, and it has found its space in the banking sector, right? While Hyperledger Fabric has found its space in other places where you have not tokenized or currency related transactions, but rather business transactions such as logistics or insurance or whatever, or reconciliation based use case or whatever. So Hyperledger, Fabric, Corda, they are very well-known names. There are quite a few again, multi-chain and private chains, Quorum, and so many of examples of permissive blockchains. Public blockchains, again, same thing. We've got Ethereum, Bitcoin. Bitcoin was the first one. I'm sure all of you know that. Ethereum is something that has revolutionized blockchain world. It has whatever Bitcoin was doing, it built upon that, and it provided much more benefits that we have today, and we can use it for our own business purposes. We've got Polkadot, so people have come up with various ideas. Polkadot, Polygon, they have come up with whatever challenges were present in our traditional blockchains. They are public blockchains. They are trying to improve on those, and they're trying to make adjustments. They're trying to include it at a greater scales. They're trying to include blockchains within themselves in order to provide those benefits. So it has, kind of just exploded, and people are coming up with such diverse, things and creative ideas that it's very hard to keep up with at times. So, what are smart contracts? Smart contract is something somewhat of a very important uh, component of much of a blockchain frameworks. If you need to understand how a blockchain application may work, and let's say if you start a business tomorrow and you have trouble over disputes and you may lose a lot of then smart contracts are basically the the savior that can save you from a lot of trouble. So what exactly does it provide? It's basically, first of all, just a computation logic, which is fully flexible, fully programmable. So that's something that you can understand. We're just basically doing coding for. It's just bunch of functions that any developer would do coding for, and it is injected and put forward to the whole network. So the network will be taking the smart contracts that you want to deploy for your own purpose, and it will store those smart contracts as part of the ledger, and they'll be able to make use of this smart contract to invoke a transaction whenever you ask it to. So let's say if I create a smart contract which says that I want to create a game or a betting platform, or maybe just a use case which is it provides provenance tracking of any assets that are being exchanged, anything like that. You would basically write functions for every transaction that is possible for that particular use case. Now, those functions themselves would either allow or disallow that whether a transaction should be possible or not. So it can have all those conditional checks that you would want. It can have all those repeatability checks, whether something has already been done. It can keep its own state impact, and it can guarantee you all the benefits that your traditional applications would have, but upon the same time it will do it in a decentralized way so that nobody can tamper it. If I've created a game or a betting platform and I've written a logic for it as a smart contract, I can go and publish it and people would start using it, but nobody can change it afterwards, right? Everybody has full visibility of it, that what is written inside that smart contract. So there's nothing that is black box for them. If they want, they can. It's fully transparent. They can go there and check out the rules. If the websites or whatever doesn't do the justice, they can go out there themselves and they can challenge any logic or anything that stands out there, and they can also put it in front of the community. So that's the kind of trust that it builds for any of the applications that you may have. So yeah, and you can basically do anything that you want. You can write logics. Let's say you can write complex logic which were pretty much impossible with traditional applications. Let's say if I publish an artwork out there in the world and I want that, okay, this my artwork is exchangeable. I'll sell it to my first customer, and that customer might sell it to someone else, and that person again might sell it to someone else. But I want that, well, if it's under so much demand, I should get some loyalty out of it. So I can create those business economics model as well, where I can get some loyalty out of this every time an exchange is done. So every time a person is buying certain that artwork for a certain amount, so that certain percentage can always be mapped to me, uh, as is it's part of the smart contract rule itself. So you can create your own tokenomics. You can go crazy with what you want to write, and just because of it that it's decentralized, right? Because we've been writing computation logic all this long, but just because it's decentralized, it opens you to the possibility of writing your own economics and your own business models, however you can imagine it. So some of the use cases of blockchain that we can go into is well, international payments. It has broken the boundary of who can transact with who. Uh, as long as you have internet, you can basically do transactions of Bitcoin or Ethereum or whatever. So regulations, the regulatory industries usually have a lot of issues with it. But of course, no government has an issue that you cannot do. You cannot transact over a cryptocurrency. They can basically never stop it. So there's no point in ever bringing forth such a law, right? You always have regulations which are about exchanges and what is possible, what is not possible, taxes that are introduced at various levels. But you can never exactly stop blockchain because it's internet. It's nothing else, right? So international payments is something that has crossed the barrier of how we do our transactions with various entities out there, and they're fully tamper proof. There's no central service. You don't have to worry about buying this service, any payment gateway or anything such. You just on a Bitcoin node and that's it. So it's pretty convenient. Capital market, so blockchain based system has potential to improve capital markets. There's a lot of currency investment going out there, and it's just not regulated. Much of it is usually stuck by the business processes themselves. So it has the mechanisms to provide you audit trails, to provide operational improvements with the help of smart contract, where accountability is not a question. It always comes as a statement. If you are building an application of blockchain, accountability is fully understood already. That's not something that you have to establish afterwards. You don't have to go to law and court at a later stage and come up with your case, that this data is in disputes. That is just not possible. If you've been working in transacting over blockchain, that's already there. And anybody can just fetch the record from the blockchain node and put it out there and say that, well, this is a proof that there's no dispute here. This is the absolute reality of what has happened. And that's how capital markets can also make benefits of it. Same thing with trade finance. So here, one of the challenges is that liquidity among the finances, components of this industry is that the liquidity is never, it's usually blocked because a lot of processes, a lot of operations that goes into our business operational flows. And if you have blockchain, you have full visibility. Any party at any point can identify, can validate and verify the data. Much of it is automatic because of help of smart contract, and some of it, which is manual anyways, can be picked up in real time because blockchain is anyways syncing all that data across to everybody in the network. So it solves a lot of issues of visibility and transparency and verifiability, which actually solves so much of issue around how to move funds across various parties, and you can have all kind of benefits out of it. Businesses can scale up by quite a bit just because of these simple benefits. Regulatory compliance and audit. So, well, audit and compliance is all about keeping a track of what has been done, trying to verify it again and again. Much of it is usually manual because it's one entity which holds the data and services, and it's another entity who has to audit it. So it's usually a process, and this process can be with a lot of hassles. So if you've got blockchain, well, you can first of all automate much of this because of smart contracts again. Because if a smart contract has allowed a certain transaction, well, it is audited with the right amount of checks already. So it has gone through all those compliance and audit checks as part of its computation, right? And it's been done so by a lot of other parties, all the parties, in fact, whatever you chose those parties to be. And some bit of audit is already done in real time. And whatever audit is done separately is again, present as part of that. You can do. You can go there. You can see the data anytime because you're just running a node which is anyway syncing all the data in real time for whatever is present within that shared ledger. Similarly, we've got insurance. So insurance is a big industry, and it's also an industry which is very primitive in a lot of manner. We have worked quite a bit in much of these domains, and insurance is one of the things. Along with banking sector, insurance was something that felt really disappointed of where we are in terms of its operation and how it works and functions today. So much of things are just done offline manually, and there's little to no accountability for much of the processes. Insurance companies themselves are not making as much profit that they can because of such constraints, right? They cannot work with each other. They cannot form consortiums, and they cannot provide insurance to large customers because they had the process is fully broken and offline and segmented. They have to reach out to the parties, set up meetings, go through every customer, decide a lead insurer, all those kind of things. So it depends upon use case to use case. The claim settlements is one of the use case. Co-insurance, reinsurance, there are a lot of use cases that are currently broken in insurance industries, and they can do it much better with help of such applications. We've got supply chain management, so we'll go quickly over some bit of these. I do want to keep mindful of some topics here. I do see that we're still halfway through only. So, supply chain management is something, I think that's one of the common use cases. So, if you've gone through blockchain, this might have come across as one of the first use cases. Um, what it does is that whatever you've done as part of the operations, whether it's logistics or whether it's storage, whether it's SLAs of any kind, whether it's detention, demurages, penalties associated with those shipments, logistics, everything is basically can be created as a smart contract. And provided the right inputs, those smart contracts can decrease the amount of disputes that usually goes along in usual supply chain ecosystems. And that's one of the big use cases. We've also got healthcare. Um, this is a this is still area of progress. It has big potential. In fact, it may have one of the biggest potential on this slide at least. But it's got its own challenges like privacy of data, because many of the data is very confidential and stored within those premises of the whoever that service company is, whether it's in hospital or anything. So healthcare is basically a big industry which has a big potential, but it's going to take some time to cross those barriers, as I just spoke. Real estate. So we have again worked tremendously on this part of industry where real estate is now being viewed as something that can be tokenized and exchanged over blockchain. Now, this may actually sound very absurd, but it is real, and there are billions and billions of assets. In fact, we Zeev here have actually done it ourselves, where we have for our customers published billions of dollars of assets onto blockchains, which are fully exchangeable across their customers, whoever wants to buy those real estates as tokens, as NFTs, or even quantitative tokens. Media and industry, the media industry loses so much of uh, money over disputes and just reconciliation gaps as well. So media industry has billions of dollars, millions of dollars of lawsuits being filed every year just because there's so much gap in this fragmented process. One company would tell you certain amount of facts about the data, other company would tell you something else. There's no single source of truth in much of these use cases. So fraudulent and cost and even the business, usual everyday businesses are impacted by immense quantity. Energy is quite an interesting one, and we'll probably go towards covering that if we'll find time in a bit more depth. But energy is again something that we have managed to actually tokenize and keep it onto blockchain. So you can be a person who is making use of making use of the power grid. You have your own solar panels, and you are making use of those energy units that you're gathering. You're putting it into the to the grid back. You're contributing to the community, and you can be actually benefited, incentivized based on that. So energy is now, which one would rather say it's the toughest out of all to tokenize onto blockchain and keep it on blockchain, maintain on blockchain. But it actually has taken great, deal of work has gone into it to in order to achieve this. And we've got energy units, various use cases, so many companies working on this area to actually make energy fully incentivized for people out there working through blockchain. Record management. So this is one of the key areas. We have record management pretty much everywhere, whether it's academic records or health records, or even wills and testimonies and so on and so forth. Everything can be created as smart contracts where nobody can be exploited. No situation can be exploited. Everything is permanent smart contract that is embedded onto a blockchain, and it will continue to function like that. Blockchain itself can create keep a proper history, and it can also try to utilize benefits between the records of one person to another. But of course, confidentiality and privacy, of course, those things have to be kept in mind in such use cases. Identity management. Now, decentralized identity is something really fancy and intimidating to a lot of customers of today, but it has potential. Not only potential, it's been used across all the Web3 applications of today, and it has proven itself. It's very well formed. There's so many standards out there. If you are, someone who's developing smart contracts for IT management, there's standards available out there, and you can basically open your own KYC company that does nothing but provides identity service, provides KYC audits with the help of blockchain. Voting, so we understand voting. We hear political parties saying out all the time, there's no transparency. There has been something exploited here and there. The vote counts is not proper. I think blockchain is perfectly stands for anonymity. At a lot of times it stands for transparency, immutability, and if you and of course identity as well, which is one of the use cases as we discussed. So if you combine all of these, voting is something that nobody can ever even make it a subject of discussion. We'll just stop hearing it on our news channels at that point. So voting is something that again a lot of people have worked on, but it's still it has to pick up by for actual production purposes. Taxes very tough to do otherwise, because again contracts are hard to guarantee, and they are usually left on individuals to ensure, or for those individuals to reach out to people who can ensure them, guarantee them that their taxes are in good hands. But if it is all formalized into smart contract, it can again do great goods. Non-profit agencies, so they non-profit agencies have a basic fund, a basic idea of giving transparency to their users, their customers, in order to get more funds and to make use of those funds for greater good. But if they cannot provide that transparency, they can only scale so much. So for them, it's the whole name of the game is that provide transparency, show the channel of funds, show the benefits of services, how it is reaching out to the actual people, businesses, and that's why non-profit agencies are also working as well. Compliance and regulatory oversight. So this bit we've already discussed under audits, but it reduces the time regulatory oversight, which is tremendous amount. You can just imagine just the government processes that you are aware of, and you can come across with a conclusion yourself about how primitive where we are, and how much technology has advanced, and how we can just bridge the gap and solve most of the problems. So yeah, that's one of the big use cases as well. Some bit of case studies that we'll try to cover really quickly. Supply chain is some of the concepts that again many of you may understand really well. So we'll try to cover that. Supply chain again, some of the big troubles here. We are counterfeiting of products. Fake goods are produced into our supply chains at the point of source, in logistics, or even at various stakeholders. And even there is reverse supply chains where you have forward and backward supply chains where you have settlements and claims being taken for the warranty of the products, and those are some sources as well where the fake goods are again introduced into the chains. So that is a big trouble for a lot of organizations. We've worked in this area quite a bit, engaging with big supply chain manufacturers like Bosch, and they have troubles. Well, even the customers who are just claiming their warranties are able to exploit them for with fake products, right? So that's how horrible the market is. And for that matter, blockchain can provide the auditability, it can give transparency, and again the immutability of everything that goes there. It itself can never solve the problem of counterfeiting, so it makes it difficult, but it can never absolutely solve it. In case you were wondering, because the problem there is also the physical asset and its virtual value, which is present on blockchain. Right? So those that mapping has to be done as well, and that comes in with combination of a lot of technologies as well. A lot of people are working in this area in order to bridge the gap between tokenizing an asset, physical asset, and putting it onto blockchain. How to do it seamlessly, how to do it with good amount of security is what people are working with. So brands, they lose a lot of market share because of fake products. Brand values decrease by quite a bit. Loss of revenue, as I mentioned. Bosch was struggling so much; they had so much trouble, but really little that they could have done at this point. And lack of consumers is again the outcome of all of this, right? So that's where blockchain comes in. And it also, does a lot of other bits that it can remove the disputes that go in today's world in logistics and other stakeholders that a supply chain stakeholder might be dealing with. That can amount to a lot of cost as well. So basically, to understand what are the stakeholders, there is also an issue of liquidity here again. That there are processes, operational processes, and verifiability that goes along, and much of these steps are usually sequential because they're very much physical at this point. And for that purpose, a lot of other use cases like getting your invoices discounted, getting loans for your businesses becomes very tough, and for that matter, becomes very tough for a lot of participants to scale their projects, scale their businesses into these areas. So it tries to digitize and also digitize with full accountability at the same time keeping the decentralization. You can be a manufacturer, you can be a distributor, you could be a shopkeeper down the line, but it will try to make sure that you are guaranteed for your own benefit, and it also can guarantee your participation in blockchain is equally justifiable. So technology structure features, or some of the structure features are, that we have technology that which forms the base layer. Then you have multiple parties who are onboarded onto that base layer of our blockchain network. Those parties then form their consortium, decide on the smart contracts. They become part of this transactional to and fro, and everything is trusted and verified as a default because it's a protocol, and and they can also publish this as public records onto perhaps public blockchains for the purpose of proving their authenticity and immutability up to that extent, because permissive protocols have an extent of immutability that they can provide and guarantee. And that's why a lot of solutions such as supply chain have found their use case that they make use of permissive as well as public blockchain both for different data sets. So yeah, decentralized, multiple owners, multiple writers, synchronized real time, trust through design rules, verified through mutual consensus between all the stakeholders, non-deletable, immutable, and chronological chain of activity. So you have full track of what has happened. So this is a typical how supply chain flow looks like, and we basically have visibility that goes missing from the very point where raw material is generated, and even we give retain some visibility back at the manufacturer level. It is still missing throughout the chain. So when things are missing, things are usually going wrong. They're going wrong by a lot of margin as well. So it's very important to bring visibility onto these processes. Supply chain tracking solution. So digital passport is how you can understand it. Works on concept of digitization. So physical good has to be captured. It has to be created onto with a digital passport onto blockchain, so it can relate to its own asset, and that asset can further be exchanged down the line. Um, that asset again might have different life cycle based on how the smart contract for it are designed. So we've got P2P power trading, but I think for essence of time, we'll probably just skip over it as quick as possible. Um, P2P power trading is that what governments have been trying for a long time. It's trying to incentivize all the people out there that use green energy, produce energy yourself, try to provide or rather uh, support the idea of putting your energy units out there in the grid so that everybody else can make benefit of it and we don't have to rely on fossil fuels so much. And it's not just the consumers that benefit from it, which are basic benefits like clean air and making money out of having a business model which is running of exchanging these energy units, but also the governments who are so much pressurized over getting these benefits out to the customers who have needs of this much amount of energy demand coming out from the industries, and so much global pressure coming out to them for the purpose of reducing their carbon footprint and such. So P2P, power trading has become quite an idea, and it works on something again that is just happening at a virtual level, most of it, and then it actually conforming to something that you can actually you have guaranteed that has been exchanged, and you can avail your benefits, your tokens upon that particular thing. So decentralized, authorize, which is again done as part of a smart contracts, monetize, which is again benefiting, incentivizing whoever is participating into these P2P solutions of P2P energy trading. A bit of an architecture you can assume, usual households who are trying to make benefit of this, they are trying to put energy units out into the grids, and smart contracts is trying to incentivize them for the energy units that they've published and trying to map them with some consumers. So you have the consumer, while at the same time you may have the producers. And often it's the case that producers and consumers can also be the same, while in daytime an entity might just produce the energy units, while at nighttime they might become the consumers of it. So regardless of that, the energy units can be exchanged in a peer-to-peer manner, because energy grid is something still common across all the infrastructure. And Discom is ultimately who is the provider of the infrastructure, underlying infrastructure of the P2P grids. And it also, by that means, should be getting incentivized, should get the loyalty of whatever transactions that happen between producers and consumers, because they maintain the infrastructure for all of this to happen. And even if you have produced the energy units, you can be left assured that it is being sold to someone. If it's not being sold to the consumers, average day consumers, then it would at the very least be sold to Discom, because it's energy grid, right? If that energy is going somewhere or the other. That's basically the functional flow. To most of it, prosumer is how we like to identify these entities. Prosumer is basically a combination of two words, producers and consumers both, and it has a certain threshold. If your energy units don't get are not observed as consumed by someone else, then they are understood to be consumed by the energy grid provider itself. So you can see another bit of an example here, how token exchange blockchain ledger works in this. So you have a full track of energy units exchange, and you also have a full track of tokens, which is the currency that you're getting incentivized also exchange onto this blockchain ledger. Some bit of blockchain of how all the microservices interact with a blockchain, typical blockchain node, in order to transact for this purpose. So some challenges in blockchain. This is the bit which is the most important bit, because this will help you realize where we are and where we're going. Because you may understand where we are, but where we're going is another story altogether. Right? So blockchain has its own difficulties in adoption, and while we were, there was so much, there was basically a bubble out there a few years back, that blockchain will do this or that, and much of what it was understood that to be just a hoax. But I can safely say today that much of the percentage of what was promised has actually converted. Even though, of course, we were one of the few that also criticized it, because that was our purpose, right? We had to criticize it wherever needed, because nobody otherwise makes benefit of it. So we were also the criticizing ones of it, and we were also the ones who were trying to empower it as much as much, and trying to scale it more. But adoption was a big challenge then. It has introduced by tremendous amount today, but there's still a lot of challenges today, and that's what this slide says. That what are the challenges? So complexity in architecture is one of the challenges. And what are the complexity that we're talking about? Because it's such a big transition from the central applications. There are a lot of questions that come about, and people usually just struggle of how to imagine the solution, not even execution or implementation side of things. They just struggle in how to imagine all of this. So with projects, you need to ask questions like, does it need to be a public blockchain or a permissive blockchain? What should be the level of decentralization that should go about this? Whether it should be fully decentralized, or it needs to be restricted. Maybe it needs to be combination of both public and permissive blockchains, your project, and that's how it would go about it. So level of decentralization matters a lot. Who all can participate? So who are the stakeholders of your particular project? Who can host a node, and who can also publish the data to the nodes? Who can publish the blocks towards those blockchain nodes? So the participation also has a lot of levels towards it. And while your customers might just be participants on the side of they just holding their wallets, their keys, or even just a username password. So you have to really decide upon what is the level of participation of each category of users and each stakeholders. That's very important to understand and imagine. And all of those have to be incentivized equally. So if I'm a customer, I'm holding a wallet, I'm having to go the trouble of holding the wallet, which is not anonymously easy. So I need to see the equal benefits of why I'm engaging in such a service. Similarly, whoever is holding the nodes, hosting the nodes, need to have some incentive in terms of mining, or staking or whatever. They need to have some kind of incentive, or even some business operational benefits, right? They need to have some incentives that why are they holding the nodes, hosting a node in a blockchain network, because it also has some costs associated to it. So blockchain and business, they often go hand to hand, and it's either the case whether that you can either understand business and blockchain together, or you can probably not understand both of them together at all. Right? You can't understand any of them. How will participants get ownership of their blockchain nodes? So this is a big challenge. That how exactly do you scale your networks? Your participants, are, that's probably some separate company, a third party organization. They don't know what blockchain is. They don't even have a tech company, tech team for that matter. And even if they do, they probably don't know how to deal with blockchains. That's a big trouble of scaling the networks and all the complications with it. Does transaction running transaction cost justify the purpose? So this again goes hand to hand with the point which I was saying, that the running cost, whether it's transactional or just running the servers, it should justify the purpose, right? It should solve the problem statements. While you can pretty much create any application with blockchain, it doesn't do you any benefit if you don't save the money, if you don't save anything out there. So, how will participants maintain decentralized infrastructure? This is again goes hand to hand, somewhat related to our earlier point, but infrastructure management has another thing to say, because while AWS and Azure and all of these cloud providers have been focusing on Web 2.0 has to offer, nobody has been looking towards what Web 3.0 actually needs, and that's where a lot of work is going in, and that's where our company is also very much engaged in. Who will an author provides who will author and provide smart contracts to the network? So that's very important. If the author of those smart contract logic is one party, then how do you come about to writing those logic? Who will maintain the versions of it? Who will be the responsible parties for auditing those smart contracts? And there are just too many things, process wise, operational wise, execution wise, that are just not understood how it would take. So all of these questions are very much answered before you engage in any project. And these are just a few examples. Actually, a lot of other planning and question and answers go before you take up any project of blockchain. Other challenges, so there are some throughput challenges as well which are associated. So we are in a state where public blockchain protocols which can guarantee which are still that guarantee the maximum amount of security when it comes to mutability and giving you availability of the services itself. That's where people go towards, right? Public blockchains. But public blockchains have a lot of issue regarding throughput, which is transactions are slow, so slow in terms of getting committed. Much of the transactions are just left hanging a lot of times. People have to have a lot of technical insight of how to exactly override those transactions. Uh, at times, there's a lot of cost associated. So you do an Ethereum transaction, and if you're doing it for your own business purposes, you will run out of business most probably, because if whatever the cost was doing that transition before Ethereum, and with Ethereum, that's a big gap that you will foresee, and that gap is probably something that most of the business cannot hold. So a lot of businesses cannot make use of public blockchains, even though their use cases might actually have the need of public blockchains. So their hands are tied a lot of times as well, right? But then came a concept of L1 and L2 protocols, right? So L1 basically said that, well, you've got Ethereum, you've got Bitcoin, which are basically just nodes connected to each other, allowing transactions to provide whatever service that they offer. But you can also have a layer 2 protocol, which also which builds upon only layer 1 protocol. So let's say if I create a layer 2 blockchain protocol, it will still have its own ledger and everything, but it will not work without a layer 1 protocol, which could be Ethereum, it could be Bitcoin, it could be anything, right? Depends upon how I've architected it to be. But L2 protocols have this capability of solving the issues of our L1 protocols, and they can guarantee tremendous amount of throughput. They can guarantee tremendous amount of performance and cost benefits as well. So L2 protocols, which are layer 2, and by that definition, you can understand that layer 2, you're still having a layer 1. So layer 1 is still there, but you still are able to overcome the problems with layer 1 while still providing the benefits of layer 1. So layer 1 security, layer 1's immutability, availability still all remains intact, while on layer 2 you get benefits of throughput and cost. How much benefits are we talking about in figures? I can give you an example that Polygon, one of the Indian ventures, has made quite a impact on global scales, and it provides you, while Ethereum it builds upon Ethereum. So there the L1 protocol is Ethereum and L2 protocol is Polygon blockchain protocol itself. And while Ethereum can only give you 15 transactions per second, 15 transactions per second, you can understand how low that throughput is, right? It has to guarantee that it has to provide that service to everyone across the world, and 15 transactions per second is too low for anyone to work with. So while Ethereum supports 15 transactions per second, Polygon can actually provide you closer to 7,000 transactions per second. 7,000, 15, there's no comparison there, right? And it can provide you up till cost reduction up to 10,000 times. So 10,000 times of cost reduction with the same benefits and all, that's a game changer. But even throughput and cost is not something that is only being taken up by layer 2 protocols. Even the L1 protocols have been working so much and are working so much, and they have got a very robust roadmap that they are working on that will reduce these costs very easily. So Ethereum has been launching its own Ethereum 2.0, which will bring forth all kind of concepts, you'll have to go back and just understand blockchains, common basic things back again, to pick whatever that Ethereum 2.0 is about. But it can guarantee you so much that it can provide the same benefits that L2 can provide. So a lot of work is going on other places, and because the community is so big in these projects that uh, you know we're gonna be crossing the barriers very quickly. So infrastructure and onboarding, that's one of the biggest issues that we've seen from our work today. We've got options, you've got variety of protocols, you can choose this or that, and your business use case probably can fit under one protocol or the other. That's still very much possible. But the protocol, creators and communities are usually built upon the protocol support themselves and whatever features that protocol supports. But nobody actually looks towards how their project will be able to consume that, scale that network, allow their customers to be onboarded on that network, and so on and so forth. So these issues impact our applications today, and much of the business use cases are actually not able to pick up because of these challenges. We ourselves have seen so many businesses. Doesn't matter if you're Fortune 500 or you're just a low-level startup. Um, you will have the same struggle that everybody does, which is how to exactly manage the infrastructure, what is the learning barrier of this thing, how to create the nodes and networks, how to learn the technology, how to scale up your team, how will you actually manage the DevOps team, which is probably residing under some other company because they also have to participate in the same blockchain network. So those challenges start coming in, right? So lack of portability of in infrastructure design and deployment is a big issue. Some company might be working in AWS, some company might be running in Azure, some company might be running with on-premise machines. But how do they all manage the deployments and still talk to each other, right? So that's very troublesome, and it will always be in P2P applications unless you have a common platform, common way of doing so. Large learning curve associated with stack involved. So that's very complicated. We have been following, blockchain tech since a very long time, and we've worked in so many protocols. I probably cannot recall the list of protocols, and I can tell that it has improved tremendously. But it is just not practical for much of the businesses today to even look into that direction of whatever learning curve it still has today. Ensuring high availability and scaling. So one of the basics, this goes without saying. If you're an enterprise, and especially if you're Fortune 500s, you have to guarantee high availability. Your business should cannot even take 1 second of downtime. If it does so, that's tremendous amount of money that you have just made a loss of. Enterprise scaling. So this is ensuring high availability, becomes very complicated in P2P architecture. That's all. We do it with Web 2.0 infrastructure as well, but with Web 3.0 it becomes much more troublesome. DevOps teams are not having any idea what blockchain is. They're struggling with what to do, what to learn, and those kind of things come upon. Enterprise grade security and support. When you're talking about P2P application communicating with each other, you have pretty much given out on a lot of communication protocols, which were standard for much of our internet, like HTTP and WebSocket. You might be going towards something else, like a lot of blockchain protocols do. So security and everything just cannot keep up a lot of times with these blockchain protocols. That becomes a big trouble. Having no in place process to allow customers onboarding. How a customer who has no idea of protocol but has so much benefit that they can avail being part of your consortium is something somewhat of an operational process as well, as much as it is technical, right? So that operational process, that in place process, that needs to be very much there to onboard your customers. Monitoring, alerts, cost optimization, very important factors that one needs to be taken in account for, because, well, our DevOps tools are primarily created for those central components, even though decentralization is nothing but those central components running at a lot of places, but aggregation and providing common monitoring and alert models is quite tough. And a lot of parties, a lot of infrastructure team of today's struggle with such a thing. And even when you have something, cost optimization is almost something that nobody's ever looking at, and there's so much cost that people are losing out on just because they're not able to even reach this point, to be honest. And even if they do, there's so much that they need to understand of how all of this works in order to produce something that will save them a lot of running costs. So that's what we do. Zeev is, one of the, well, I can probably say, although it may sound like some boasting, is that we are the one of the first parties who thought about these challenges, because we were doing a lot of blockchain products and projects a long time back, and we came to this realization that it was just not possible for us to provide at enterprise grade support and security and services unless we have that niche level of idea and that niche level of framework which can guarantee all those things, right? So we create that base layer and we formed a separate product and eventually a separate company, which primary job is actually just to serve other blockchain companies, other businesses, other developers, other DevOps engineers to be make benefit out of these engagements, right? So that's what the platform is. What you can understand is that what AWS is to Web 2.0 world, we are AWS of Web 3.0 world. That's how we imagine ourselves. And we've got a lot of work to do, and there's still so much of things that we have imagined already, and we've got to keep up with those demands. And at the same time, there's a lot of things that we still haven't even imagined, and nobody has. And we still have to look towards that, and we have to lead the way in those directions. So that's what it takes. We have this product itself becomes a way of you to decide of how to do your development of your decentralized applications and how to then implement and execute with all the security intact. So that's what we do. We specialize in what blockchain platforms need to be, and what you can understand is that we, again, because it's a layer that sits above all the clouds, a customer may have AWS, Azure, or some other kind of cloud hosting, but they can be part of the same blockchain network. They can even authorize their own cloud accounts if they want. They can choose whether they want on-premise deployments or not, and they can still be part of the same consortium, same networks. They can share, put out easy network sharing invites that can go out. People can accept those invites, and they can spawn their own blockchain nodes that they can make benefit of without having any knowledge of what is the complexity of running that blockchain, or what is the complexity of maintaining smart contracts, what is the complexity of ensuring the uptime, security, uh, you know, all of those kind of things. So yeah, that's where we are. We've been working tirelessly with some big Fortune 500 companies out there as well. Some of the examples you can see: Intel, Vodafone. We've been also, blockchain is one of the things that we are working in. I should mention federated machine learning is one of the things where machine learning itself has become decentralized, and it is picking up quite a bit. And we're also leading that space of how to allow those kind of business models, those kind of services to exist in the infrastructure. So decentralized application is the name of the game. Blockchain is still a subset. We'll be seeing a lot of work going into this kind of area as well. So some bit on how you can understand the platform is that, of this is that you would want, if you're thinking of a project, it can never be an industry grade project unless you yourself have provided enough time to what it needs at each and every component of blockchain, or you have actual availability of service of any such provider who can give you those guarantees of uptimes and security and such. And that's where you see it's not only us. You'll see a lot of applications, a lot of work going in. Community has been working and bringing on so many services that decentralized application can utilize without even having backend servers at all. People are creating business applications, modern blockchain applications, which are nothing about backend applications, and they just work as front end, just websites, and everything is provided to them in a decentralized manner. And that's where all the economy is shifting. There's no backends anymore. Uh, Sorry to say, but you might have put a lot of time into it, invested a lot of time, but that's where we'll eventually lie after at least a decade or so. Still, a lot of business models still needs to work in and function in that manner, and they are not going anywhere there anytime soon. But that's where eventually all of our economy will be, P2P. So yeah, these are some bit of customers you can see. Just we are one small company. It's not cannot call ourselves small anymore, but uh, just a force of habit that we've been calling ourselves for so many years. But these are some companies that we've been dealing with, and you can imagine that. if we're dealing with them, then how many out there are actually working with as well? There's so many works, so many projects. Doesn't matter if you're a small startup or if you're a big enterprise company. People are working in blockchain projects, and they have so much demand of these skills and uh, benefits. So yeah, that's about Zeef, and I think that covered quite a bit. I think we did pretty good on time as well. I may have not go into the depth uh, as one may have been looking forward for, but that's what the Q&A session is for. So if you've got any questions, feel free to ask them, put it on chat. I'm not sure what the current model here is, but please feel free to put them out.
Thank you, sir. That was a very wonderful insight to the world of blockchain. I am sure it has definitely sparked the curiosity in the minds of the audience. So, guys, let's start with the Q&A session now. I have the questions. So, yeah, the first question is from Sana. Despite there being so many different protocols, why are ERC token standards mostly used?
It's a very interesting question because it actually goes towards what these blockchain protocols are and what these ERC standards are, right? And that would give to any developer a good insight of what exactly are smart contracts as well, because ERC standards are nothing but a way of a protocol in itself. And protocol is a term that you can utilize loosely with anything, right? You deciding on how a to and fro communication should happen as a protocol, right? And ERC are just bit of standards. And if you wish to launch a protocol of yourself, or even if you want to launch a token on a separate protocol, you can still make use of these standards as part of your protocols, and still be able to make use of it as it is utilized in Ethereum. ERC, for many of you who don't know, are standards that are published by Ethereum community, who uh, provide the support and provide various ways for you to write efficient as well as secure code in order to ensure that your smart contracts for your tokens are very well secure. So that's a community-driven benefit, but it is then used by a lot of other people to make use of directly or with some customizations. But a lot of other protocols are still working on them. They are creating these concepts of standards of smart contracts themselves. They do it not necessarily by calling them ERC standards or anything similar, but they do create a lot of example projects inside. So it's a standard. You can always take it, towards different blockchain protocols yourself if you want to do so.
Okay, I hope that answered the question for Sana. So, our next question is from Sudhanshu. How is a Oracle node different from a normal node?
So that's a very interesting question. So it's about, I'm sure I'll be hearing a lot of interesting questions, and I won't stop in acknowledging them. Uh, what blockchain nodes are is basically something that they interact with each other, and they eventually need some source of data, right? And that source is something that you're still trusting upon. You can always have it done in such a manner that you multiple sources are validating and verifying whatever is being put out to the blockchain, but it is still some coming out of somewhere, right? Let's say for gold-based supply chain, you have to decide what are the invoices, what is the rate of blockchain, and how much a certain person should be charged. Now, the rate of gold is something that the blockchain as a tech doesn't know, right? It's a market value, and that market value of the gold has to be coming out of somewhere. So you need these gateways that you can create that can provide these channels for you to get the data out from and to be put forward towards blockchain. And that's what these Oracle nodes are. They're responsible for putting out, injecting these data streams into your smart contract so that smart contracts can know of this data. Okay, this is the new rate. Based on this, I need to take this into consideration and do whatever I need to do. And that's what Oracle nodes provide.
Right. So, our next question is from Akshay. How can we as developers implement Z-Way in our relatively small scale projects?
Okay, so it depends. So right, so your small scale projects can be understood as small scale because of the number of users it may have, although the complexity of the use case still might be quite huge. Or it may be because you are using it for your own purpose. For The complexity of the business use case itself is not that high, right? There are two different answers to this. That what do you mean by small scale project? One is that complexity isn't that high, the stakeholders and all are not that huge, and the participation is that the number of customers that it's supposed to reach is not that high. So if you're someone who's creating a protocol, who's trying to establish this business network, as you may want to call it, you would want to understand the stakeholders, decide on your protocol, and you want to go about selecting your blockchain protocol, and then you want to understand who are the stakeholders, what their infrastructure choices. What Zeek does is that it allows you to have that kind of compatibility. Doesn't matter which cloud infrastructure you have, whether it's AWS, Azure, or whatever. You can pick that particular cloud. You can authorize that cloud account where your resources will still be running in your own account, while still you'll be participating in that in that network. So we provide that automation, and blockchain is again just a subset of that. We provide services for a lot of other bits. So decentralized file system storage is one of it, where you would want to share the data across it, and we would work in quite tirelessly on to some other services as well, which is like cryptocurrency exchange and other bits as well, which are usually required in a decentralized application. So we are not tackling one as a deployment of blockchain or anything. It's a combination of a lot of services that are combined in one platform.
Right, sir. So, any further questions? Yeah. Is there a
Uh,
way to make NFTs more interactive or diverse?
yeah, so very creative question there, and well, I would say that yes, there are a lot of ways, and what is this limitation is rather perhaps the stronger question that you may want to ask, right? And that is not fully realized. What are the limitations of making these NFTs more interactive and diverse, right? Because it's people are just going by whatever they can imagine at the moment, and their imagination is still something that is limited. NFTs can be, it's basically, so it's combination of blockchain tech. If you can engage with other decentralized services such as IPFS or similar P2P protocols, you can combine all of them together. And what you can basically do is that you can give users the experience of that they're able to make use of the files that are required by your browser, let's say, and those files will give you an experience of AR or VR for your consumptions of your users. So you can make them that interactive. So your physical asset convert it to virtual asset, and that virtual asset itself is something that you can have full feel with in that manner as well. So NFTs are not really necessarily for physical assets, but you can give that kind of engagement again. So you may want to look into some other tech, which is not only blockchain. You may want to look into some other P2P protocols, such as IPFS, such as AR VR tech, how it can be utilized and hosted in a decentralized manner to make it more interactive.
That was a very good answer, sir. So, another question from Arjun. Blockchain services these days are using AWS or GCP, some or the other way. How to move from this to complete decentralization?
Yeah. So yeah, that's what the question is, right? So it's kind of the same criticism that Bitcoin has gotten, that China is having most of the hosting of the nodes, and holds much of the mining capacities, right? So questions like these, comes about the nature of the protocol, and it's the protocol itself is actually one which is at weakness here, right? But this question is more about the on the infrastructure side of things, because people are more used to Web 2.0 side of things. They're usually fixed with their own vendor, with their own partner, which could be AWS or GCP or even their private premises. The solution to this is that you don't want to pull them out of this thing. It does its own benefits. AWS GCP provides a lot of security benefits that would be otherwise very tough. You'd want to give them options, right? So one participant entity might be going towards AWS. One would say, okay, this is a new cloud that has been launched, and there's so many options out there. It's tremendous amount of quantity of clouds available out there. You can select for them, and if it is that easy, just clicks, and you can basically just ponder your node there, and that's it. That's where you have it. You can set the region, and for the same thing for the on-premise deployments, you can host your nodes locally if that capability, that linking is, and that's what we are trying to do. Is that you're not limited to one cloud provider, you're not limited to one customer. You can have that kind of options.
Right, sir. Yeah, another question. Is it possible to have multiple blockchains linked by an aggregation layer? If so, how do the nodes of the different blockchains interact with the layer?
Yeah. So, well, first of all, if you've imagined this thing, very well done, because you've imagined something original that people did, have been working it for a long time. But it's one thing to come to these kind of ideas yourself, right? So this has been something that a community has been working quite a bit in. They have come about to so many ways of working towards it. People are creating parent chains which can hold these blockchains as part of it. That's one way of doing it. And these parent chains can actually bridge the gaps that these subchains have. So Ethereum being, as you can understand, one of the substrates within Polkadot. Polkadot is one such project that I'm speaking of here. And there are a lot of other projects as well which can create these decentralized gateways that can allow you to bridge the gaps. Create these gateways between transactions from one source blockchain to another destination blockchain. So there are a lot of projects. There's still some of them are in infancy, but a lot of projects have matured really, really well. Like I spoke, of, Polkadot being one of them. So aggregation layer, yes, Polygon is one of the best example of this. They reduce the transaction cost and performance as I discussed over the presentation, and yeah.
Okay. Yeah, we have one more question. With the use cases of blockchain increasing, will IPFS VR used everywhere in a few years from now?
Well, um, it's a P2P protocol, and we've seen this pattern is that technology, well, it becomes specialized for certain thing or the other, and when it becomes specialized, a lot of other technologies find their own spaces, their own communities, and their own use cases that make sense for them to actually work upon. So yes, IPFS is definitely one of them, and it's not the first one when it comes to it. We've been using, we've seen torrents and all. They were nothing. They were just P2P protocols connected towards internet for sharing data, for that matter. So that technology has always been around. IPFS talks about providing it in a way that, in a certain way that mostly tap applications and others can use, your browsers can utilize better. So definitely IPFS is expected to be one of the biggest contributors, but we'll have to see, how the use cases fit and where it doesn't fit at the moment. It's more about imagination and relevance kind of game at this point.
Right, sir. Yakshesh is asking, can DeFi will ever able to replace the traditional banking and finance system?
Yeah, so I'd say definitely because it can definitely. So the question is, will ever be able to? It will. It can definitely be able to do it, but there can be also always cases where you don't want to specifically, and it's not the case that people have malicious reason to do so, but there can be a lot of justified reason why you would want to keep it centrally regulated for a lot of reasons as well. Um, but yes, the tech itself has progressed so much, and there has been so many DeFi projects that are ongoing at the moment, which have already made billions of transactions using such. So it's already doing it by quite a bit, and it's doing it very, very efficiently. I must add, it has decreased our transaction cost by tremendous quantity, intermediaries and whatever had to go in between. And one of the benefits I just like to mention here is that your transaction cost increase with the amount of transaction that you're doing it for, X number of dollars, with banking sector specifically. But with such DeFi such projects, you can have it such that doesn't matter the transaction workloads, uh, the size of the transaction, your cost will still be remain very small. It won't increase with the size of the actual transactions, which is very, very formidable thing in itself. So yeah, it can definitely remove it. Whether it will or not, that's not really a question. I think for debate, there will always be use cases and purpose for all of them.
Right, sir. So, yeah. What is double spending? Is it possible to double spend in a blockchain system?
Right. So yeah, double spending is about you trying to well, first, I think I'll have to give a little bit of background upon how Bitcoin or much of the cryptocurrencies work. Right, they take certain inputs, as you can understand. Inputs. When I say inputs, you can just understand some data structures, some objects, or something that is stored within the database, and they take these inputs, and these inputs are nothing but some value which is associated with them. That is 5 Bitcoin, 6 Bitcoin. So they gather all these inputs that are associated with one address, and they try to convert it into something of an output, right? And this output itself will now later on become inputs to some later on transactions. So even the output itself would have certain amount of currency associated with it, which is let's say 10, 20 bitcoins for this address, 20 bitcoins for this address. It depends upon the kind of transaction that you've done. So input and outputs are the models that it goes by. Now double spending is a way that whether you can consume the same inputs to in multiple transactions. So that's basically saying that I have 5 Bitcoin, and can I send these 5 Bitcoins to some party A, and can I send the same 5 Bitcoins to a party B, or maybe just party A itself, and I want to send the same 5 Bitcoins to party A itself again. That's double spending, right? You would want to stop that, and it would be a challenge, as you may understand, to do it in uh, cryptocurrency where you have everything decentralized. But there are a lot of algorithms out there that do this, very easily. Nobody ever even comes to questioning this. So double spending is that concept, and yes, blockchains have been doing it, you know, from the very beginning. Bitcoin is Bitcoin today because it has been doing it from the very beginning itself. It has a lot of algorithms. It has a lot of checks in place in order to stop these double spending process. It does it by something called as a cryptographic proof, cryptographic anonymity, randomness rather, which is nonce. So that's a concept in itself. But that's just basically saying that once a nonce gets consumed, it cannot be consumed again in a second transaction. Very simple solution to a very complex problem.
Right, sir. So, thank you, sir. That was a very interesting Q&A session. Unfortunately, we won't be able to take any further questions due to time constraint. So, yeah, once again, sir, thank you for your valuable time. Guys, that's it for now. I hope
Right.
this had been quite valuable for you all also, and I hope to see you in the blockade on 9th and 10th July. Thank you, guys. Thank you, sir.
Thank you. Thanks a lot. Have a great time, guys. Bye bye.
Oh,